Michael joined Broadcom in 2001. He helped to bring Broadcom from its start in the wireless LAN technology to its current position as the market leader. In the process, he led Broadcom to a number of industry firsts, including AO2.11g, 500 million units shipped, AO2.11n, and Wi-Fi Bluetooth combo chip. Prior to joining Broadcom, Michael was the Vice President of Marketing at Orange Semiconductor, where he was involved in the technical innovation in both broadcast digital television and wide area wireless market. He also served as the Director of Marketing at IC Works, where he developed spread spectrum clocking technology and co-authored several papers on the subject. He holds an MBA and a Master of Science degree of Electrical Engineering from UC California at Davis. Michael's topic today is Trends in Wireless LAN. Let's welcome Mr. Michael Hurlston.
Okay, so first I wanted to give a couple of sentences on Broadcom. As the introducer mentioned, I'm with Broadcom. I've actually been with the company for about 10 years, and I've seen a lot of evolution in the company over those 10 years. But you can see now the company has moved into the Fortune 500, one of the largest companies in the United States. Its rank is somewhere in the 300s now. We closed 2010 with a net revenue of about $6.8 billion, and I think the last couple of quarters we've been on track to close 2011 somewhere around $8 billion. So we've had a lot of growth over the last couple of years. You can see here in this particular chart, we're just short of 10,000 employees worldwide. We've got a big presence in China, and we've got several design locations there working on things like set-top boxes and cellular phones. So China is a very important market for us from both a design engineering standpoint and also from an end market that we try to sell into. This chart shows a ranking of the semiconductor companies. For the first time, Broadcom actually broke into the top 10, ranked number 10. We're obviously very proud of that fact. And the growth that we experienced last year in the 2009 to 2010 period was phenomenal, 53% year over year. So we really were growing quite quickly, and I'll explain one of the big growth drivers for that in just a second. We believe that there's a convergence happening between the home, products that serve the home market, infrastructure, products that serve the enterprise, and the hand, truly mobile products. All three of these things are actually converging, coming together in some way, shape, or form. And Broadcom, as a communications company, communications integrated semiconductor company, we're driving that. We're trying to bring those connections, we're trying to make those connections more seamless and simpler for end users to take advantage of. So this convergence is really what drives our company philosophy. Okay, now speaking a little bit about Wi-Fi. I'm in charge of the Wi-Fi business. Wi-Fi has been one of the most talked about markets in semiconductors for the last 5 years, and to the degree I can, I'll try to explain some of the dynamics, certainly some of the recent dynamics that have driven the market. Okay, so what do all of these products have in common? Smartphone, television, digital photo frame, set-top box, a weight scale. I'm trying for that weight that's reported there, a little ways off. Refrigerator, microwave oven, washer dryer, PCs, tablets, Blu-ray player, and even kind of, I don't know, buggy looking model airplane. I don't know what that is. What do all those have in common? Any guesses?
Semiconductors.
Made in China. No, all of these products have Wi-Fi. All of these products have Wi-Fi. And you can see really what's driven this market has been the proliferation of end applications that have Wi-Fi in it. The number of devices that this particular semiconductor, this particular communications IC is serving is wide and numerous. Okay? This gives some representation of how all wireless semiconductors have grown. If we look at the 2008 time period, we saw Wi-Fi in some of the end products that I described earlier, maybe some Bluetooth and things like phones, perhaps in automotive as car kits. But if we look forward to 2014, you can see Wi-Fi going into a whole host of end markets, as well as NFC, near-field communications, as well as GPS, as well as Bluetooth. Wireless semiconductor, wireless communications are going into products that we never thought possible. I heard the tail end of Jody's speech. Medical, a very big area that now wireless communications is starting to serve. So lots of different end applications that we're going into and targeting. This is another interesting factoid, kind of a backwards look. This is a Time magazine retrospective. They do the best pop singer, the best, I don't know, the best car, whatever. This was the top 10 gadgets of 2010. And this is the list of those 10 gadgets. You can see an iPad, Samsung Galaxy S phone, blah, blah, blah. Lots of different devices here. Well, 9 out of 10 of those devices that Time magazine picked have Wi-Fi. You can see how important it is. Of course, as a commercial, 6 out of 10 were Broadcom, so we're very happy about that too. Okay? But you can see just how prevalent this technology is becoming and how it's serving some of the most important and well thought of gadgets that are out there. This is a representation of just how much the market is growing. In the next 3 years, we expect that 3.8 billion units of Wi-Fi semiconductors will ship. This is actually not our data, this is from ABI Research. And what that represents now is the biggest market, surpassing cellular, for semiconductors. Cellular has often been thought, the cellular baseband has often been thought of as the most valuable property in semiconductors, but that's actually undergoing a transition now, and we see Wi-Fi will catch and pass cellular because it's going into more than just cellular phones. It's going into a lot of cellular phones, as we'll discuss a little bit later, but it's also going into these crazy other applications like microwave ovens and refrigerators and so on. So that's what's really driving this market. This is how we like to think about the business and the segmentation of the market. We started up in the upper left corner in what we call our connectivity area. And our connectivity area has to do with data communications between two devices, serving things like notebooks, printers, home gateways. This is sort of the core market where Wi-Fi started. And then it migrated down to the lower left corner, what we call the mobile business. And we saw ultra-portable devices like smartphones, like tablets, digital cameras, e-readers, start to take on Wi-Fi as a way of connecting to the internet. And then we migrated to the top right, and we see consumer electronics devices like television, Blu-ray players, things of that nature that are primarily driving video and video applications. Those devices and applications start to integrate Wi-Fi. And then finally, as we move to the lower right corner of the chart, we see embedded. And this is a new market for us. A new market for us as an industry where we're going into applications like medical, home security, some of these appliances, sports monitoring equipment, and so on. So you can see there's been a constant evolution in the wireless LAN market. And as an industry, we're continuing to find applications and end devices that will take on and are looking for this kind of connectivity. Okay, so talking a little bit about one of the new markets, which is the consumer electronics area. Why is that happening? What are the interesting drivers that are causing Wi-Fi to be integrated into TVs and into set-top boxes? Well, we have a phenomenon that we call over-the-top video. And this is video that's really internet-driven. It's an experience that's coming from YouTube, as this particular chart shows, or Netflix, things that are typically IP-related, Internet Protocol-related, coming from the Internet, that people want to experience rather than on a small screen like a PC, they want to see on a TV. And we're seeing more and more applications come into the TV, particularly around multimedia and video content, and this is really driving an attach rate of wireless LAN into TVs. And we even see Bluetooth actually coming into TVs for applications like the Bluetooth glasses for 3D TV or for remote controls, Bluetooth remote controls. So connectivity, wireless connectivity, is coming into TV sets in a fairly significant way. You can see at the bottom, I hope that's coming up, 65% of Netflix members watch their movie that they rented or movie that they ordered not via DVD or some kind of hard media, but by streaming it over the internet directly to a TV or directly to some wireless receiver. So this phenomenon has really caught fire. There's obviously been a lot written in the press about how important this streaming phenomenon is to companies like Netflix. This chart shows just how big we think this market is going to become. The worldwide TV market today is somewhere in the order of 200 million units, and you can see a very explosive growth in that market this year and into next year, where wireless LAN is coming into the digital TVs, particularly larger form factors. And then as we look out in outer years, it starts coming into the set-top box, the Comcast or EchoStar set-top box that one has to bring the service into the home. We see wireless LAN now starting to get into even those kinds of products. This is a chart that's talking about how people are consuming or what people are using tablets for. What this points to is that tablets are being used by most people in the home for media consumption. Okay? You can see the various percentage. We went out and surveyed millions of people on the street, or actually somebody else did, Jeffries in this particular case, and they came up with this chart. And it's really indicative of how people are using products. They're using these things for multimedia and in the home. And this chart captures that very, very well. And one of the ways, of course, in the home that you're going to see content on a tablet is using the Wi-Fi network. And so every tablet today has wireless LAN as a means to connect to content or connect to the internet. Now shifting to the cell phone market. The cell phone market, if you remember one of the charts that I showed earlier, was one of the later markets to take off for Wi-Fi. It really only started happening in the 2008, perhaps 2009 timeframe, where we started to see cell phone OEMs ask us for Wi-Fi chips. But this market now is the biggest market for Wi-Fi semiconductors by far. And you can see the attach rate here, and this is perhaps conservative based on what we're seeing. Every single smartphone is taking wireless LAN. The ratio of smartphone to a Wi-Fi chipset is now 1-to-1. And depending on how we model a smartphone market, that number, this attach rate, the percentage of overall semiconductors, overall smartphones or overall cell phones that will take wireless LAN will increase. And not only that, the Wi-Fi technology is actually moving down into feature phones and even in some case basic voice phones. Some parts of the world are using social networking over Wi-Fi, even in very basic voice phones. So we're seeing a big shift of in the cell phone market attaching Wi-Fi. Why is that happening? Okay, these three trends really capture why we think Wi-Fi is coming into the cell phone market. First, we see this prevalence of larger screens and touch screens. Second, the carriers are looking to offload traffic. They're trying to push particularly data traffic off their cellular network and onto an IP network. And then third, some new usage models or some new applications that we're driving as an industry that are making Wi-Fi much, much more attractive to both the carriers and to cell phone OEMs. Okay, so the first trend, the larger screen, the touch screen, that really changed a lot of the dynamics. First, it drove applications. It also drove web browsing, a much better web browsing experience. Well, both of those things, downloading apps or browsing the web, are very conducive to Wi-Fi. And so we saw the OEMs, the cell phone OEMs, really start to push, hey, maybe we need some new technology here in the cell phone to enable some of these experiences. Okay, second, this idea of cellular offload. I think we've all had this experience of trying to make a call in a congested area, whether it's coming up and down 101 or in San Francisco. The cellular network is getting very, very crowded, and it's becoming problematic for the carriers. They're looking for ways to take all this data traffic, all this web surfing and downloading of applications that I talked about in the first slide. They're looking to move that traffic off their valuable cell network that's driving voice traffic and move it onto IP. And what better way, really, than Wi-Fi? The chart that spun up as I was talking is very indicative of that. As you add users on a cell phone network and you start trying to download, each user that comes online is having that capacity. Each user, now there's only a fixed capacity for every cellular tower, and if I start adding more and more users, the slice of capacity that each individual user gets smaller and smaller and smaller until you're talking about a very narrow pipe and ultimately a frustrating video experience or web browsing experience. And so having Wi-Fi as an alternate technology to push traffic in a different way obviously is very compelling to the carriers. Finally, okay, some new use cases are coming up that are driving different revenue models for the carriers or different experiences for us as a user. First, media sharing. Okay, so as an industry, the Wi-Fi semiconductor companies are looking for ways to make it very, very easy for you if you take a picture, for example, as you're out and about on your cell phone, and translate that or move that to a TV or some movie clip of, let's say, your children playing soccer or something like that, film that and then move it to the TV such that you can have a better viewing experience and perhaps share it with the rest of your family. As an industry, we're really working on that media sharing idea. Second, this concept of a mobile hotspot. So you can see advertisements now. There's been a lot from some of the carriers, Verizon, AT&T, about having your phone actually act as a little hotspot. It connects to the network, let's say via 3G or 4G, and then it becomes a little Wi-Fi hotspot for you to connect a tablet or a PC or some other device that you might have when you're out and about traveling and maintains connectivity. This is very useful. Quite often there's an extra plan or an extra fee that the carriers are driving or asking for if you have one of these hotspot technologies. And finally, in the upper right is something that's very interesting, which is the combination of wireless LAN and GPS to be able to produce a better indoor location. GPS is great outside. If I'm running around outside, GPS is a perfect way to find where I am on the roads or things like that, except maybe in Taiwan. I never can get this GPS to work there, but that's a different story. But indoors is a big issue, and the shopping malls and people who are trying to do advertising indoors are looking for ways to spin coupons as you're passing their store. And it turns out that if I use GPS and Wi-Fi in some combination, I can do that. I can locate almost with perfect accuracy where I am walking through a mall. So this is another big use application that's coming up that we're driving using wireless LAN technology. Okay, what's coming up? What are the circuit challenges that we're trying to solve to get into some more of these areas? The embedded market that I talked about, medical devices, sports monitoring, home security, these have some new challenges that I'll explain in a minute that are really driving more innovations in the industry. First, you obviously need very, very low power. Some of these things are powered off of watch batteries, and we have to get the power down. And so what we're certainly working on and as an industry is getting the process technology down. I think Jody was talking about that earlier. Shrinking and shrinking the geometries, that helps the power. And then circuit design techniques, getting our circuits better and better. One thing that we've done is been able to manage to combine multiple RF technologies on a single device, like Wi-Fi and Bluetooth, Wi-Fi, GPS, Bluetooth, combine everything on one circuit, which really helps in terms of power consumption. Okay, second, battery life, again, a big issue. One thing that we're doing here is investing in what we call power harvesting, taking energy that might be electromechanical, turning on and off a switch, or RF energy, and harvesting that to use to keep a battery charged, to keep it alive. Okay, and this is a big area of innovation in semiconductors in general, but it's very applicable to what's happening in wireless communication semiconductors. Footprint. Obviously, we're trying to get into smaller and smaller and smaller areas. This is something that's key. These phones are getting smaller, and as we start talking about sports equipment or medical devices, these are very, very tiny devices. We have to get the area of our circuitry down. And again, as we start talking about moving down the process curve, that helps. Circuit design, circuit advances, all of these kinds of innovations are certainly helping us in the footprint area. Software. One of the big misnomers when we start talking about semiconductors today is that there's no software. It's just all hardware. Well, that's not true. On my staff now, 50% of the engineers that work on wireless communications are software engineers. And software is probably the biggest problem that we face. And in this particular idea, if I'm going into something like an oven or going into a refrigerator, I don't have an Intel processor to offload my software stack and run my communications protocols. I don't have a smartphone processor to run my Wi-Fi stack. And so what we're doing now is looking at ways to embed microprocessors, very small microprocessors, into wireless communications chips in order to host, primarily in order to host the software stack. And then finally, cost. Cost is a key issue. As we start going into some of these very, very low footprint, low profile types of applications, cost is something that obviously is a main consideration. And all of these things that go before really are also intending to drive the cost point. This is a slide, if we didn't remember from before, again, talking a little bit about some of these applications. One thing that I wanted to focus on was the smart grid. And smart grid is an area where we're investing very heavily as a company and as an industry. There's a lot of activity in terms of how does Wi-Fi play in smart homes. This is one very complicated chart, diagram, but here, obviously in California, the smart meter is already here. There's been a tremendous amount of publicity here in the Bay Area about PG&E smart meters and whether they're working or not, whether they're overcharging people or not. That part I don't know. But I don't want to get in the middle of that controversy. They're there. The good news is they're there. Now, there's actually 2 radios in every one of these smart meters. One that goes back to the utility to serve as sort of a mechanism by which they can collect billing information. But there's also a second radio that goes into the home that's a connection to device, ultimately will be a connection to devices within the home. And the idea here is, as my billing rates change, you can look at that and make decisions about what to turn on and off, depending on what time of day it is and how much electricity is causing it at that particular time. Now, this whole thing is very near and dear to my heart. As I mentioned earlier, I now have one of these electric cars. It wasn't very good today, okay? But normally, this electric car is a big problem because as we convert to electrical cars, the tap in the grid, if I come home at 6 o'clock and I park the car in the garage and I start charging it, and everybody's doing the same thing, the load on the grid will be enormous. So this is why the utilities are very concerned, and they're taking measures now to control and make sure that people are charging things at different times, turning things on and off at different times, all in an effort to keep the grid very, very manageable. And one of the interesting things about this electric car phenomenon, one, that you can get a charger actually installed for free from one of the government agencies will come out and actually install one of these chargers. They do it under one condition, and that condition is that you have a Wi-Fi network. Okay, because they want to connect that each one of these charging stations has Wi-Fi in it, and they want to have a connection to monitor usage, and then obviously if the load on the grid comes up too high, actually shut off the connection. So it's pretty impressive, but it's a good deal because these things would cost $5,000–$6,000. They're giving it to me for free, so I'm very happy about that. Okay, what's coming next? Okay, we talked about sort of a picture of the market. I want to just take a couple of seconds to talk about innovations that we expect over the next year or so. Okay, this is a very interesting chart. Okay, content. Every young American, or on average, young Americans carry 1,159 songs, 51 videos, and 1,188 photos on portable digital devices. Okay, many devices capture and store content on the go. We know that very well. Handsets, cameras, all these different things are all about creating content and consuming content. Okay, 75% of young Americans would give up coffee before giving up Wi-Fi. Now, I don't know if that's true for me. I'm not young anymore, so I definitely can't live without my coffee. That's a no-go. Okay, 85% are more likely to carry a handheld digital device than a watch. Okay, my watch is locked inside my house, so I'm without a watch at the moment. 67% spend more time on a Wi-Fi enabled device than on a TV, and this number is obviously climbing. I mean, people are now consuming content not on the TVs, but on tablets, as we talked about earlier, notebooks, everything, right? So there's just a proliferation of things that are happening that are really creating a very dynamic environment. Okay, now this one is good because it's actually in China. My graphics department had a field day, okay? They started taking crazy pictures of me and putting them on these slides. And, it's not so good. So I'm not so very good at Chinese. Hopefully most of you can read this. I think the idea is, obviously there's all these different devices we've been talking about that have Wi-Fi and how to connect them all together. Okay, how do we go about connecting them all together and making those connections as easy as possible to move content from one thing to another? Well, if we look at kind of the traditional way of doing that, I have to move content from one device up to an access point and then over to the second device. And I have to log on to a network, I have to log on to a hotspot. It's somewhat cumbersome. Okay, we probably all have Wi-Fi networks at home. Each time I bring in a new device, I have to get on, I have to put a security key in. It's somewhat complicated. Okay. Well, the good news is we're creating as an industry a new technology we call Wi-Fi Direct. There's me now smiling. I'm a very happy guy. A new technology that's basically taking away the need for that access point. Taking away the need to go first from an access point and then to another device. We can now connect things one-to-one, peer-to-peer. And this technology is called Wi-Fi Direct. It's coming now. Some devices are getting enabled with it as we speak. I think as we look out at 2012, this will become extremely prevalent because I want very easily now, if I'm on the street and I have some file that I found, some interesting video clip that I found on the internet, I want to share it with a friend, I can do that without having to go to a hotspot. I can just send it directly, not through the cellular network, but a very easy connection using this Wi-Fi Direct technology. So this is something that we see as becoming very, very prevalent very soon. Okay, next. Now, Wi-Fi Direct is something that's going to enable a tremendous amount of additional content. Okay? We really think that as more of these devices are connecting, not through an access point, not through some central hub, but able to connect to one another very, very easily, we think that this is going to drive a lot more bandwidth. And so a new wireless standard is coming online we call 802.11ac that's shown here in the right column. 802.11ac offers somewhere on the order of 5, 6, 7 times as much bandwidth as the current 802.11n technology. Okay, it's tremendously more powerful. It's kind of equivalent of going from 100 megabit Ethernet to gigabit Ethernet. It's a big, big step up in terms of the speed. And this is a standard that's being worked on now. We expect ratification sometime in the end of 2012, early 2013, and we expect products to be hitting the market somewhere at the same time. Okay, so this 802.11ac is really a very new evolutionary wireless technology that we think in many ways is going to start really eating into even wired technologies and competing directly with Ethernet because of the speeds and bandwidths that it affords. One of the very interesting applications for 802.11ac, if you think about, particularly here in the US, a home will have multiple set-top boxes. I might have one TV in the living room, maybe one TV in a bedroom, maybe the kids have a TV, maybe there's one in the office. There's multiple set-top boxes in a home. If you think today, those set-top boxes are usually wired up through some coaxial cable. And when that happens, that takes a long time. Installers take hours to come to your home. First, you have to wait for them for hours and hours and sit there and waste your time. But then they show up, okay, and it takes them hours, okay, to put this technology in and link up multiple set-top boxes. What 802.11ac affords is the ability to do this using wireless. I can just come in now as an installer and set down the set-top box, enter a few security codes, and have it link up to a main set-top box that might have a hard drive in it or link it right up to the network. So rather than come in and spend hours trying to drill holes in walls and run wires throughout a house, I can now come in as an installer and do this using wireless technology, which is terrific if I want to connect and view from a central hub like a PVR, or if I want to come in from a backbone like a satellite or an IP network and really create internet content that has, or internet content or programming content that's coming from a source to multiple destination devices. Okay, so I want to thank everybody for bearing with. Thank you very much.
We have Dr. Dong-Ing Chen come here to present a plaque of appreciation for Michael.